like once we have a class, you need to practice on your own. Maybe you can come with some questions and we can have some discussion before starting the next day class. So that's how we'll plan. And apart from that, yeah, you'll be assigned to some assignments and you need to complete them. Yeah, then only you can yeah, like so apart from other technologies, this is the thing, like you need to concentrate a little bit more because like it once you get in, you will not get fixed issues. So it depends on the situation and it depends on the environment. There might be different kind of issues uh, you will be get into. So yeah, if I say randomly, like I will give you a few examples, but yeah, I'll not guarantee you will get only those issues. So you have to think in that way, and then yeah, if you cooperate with me, yeah, maybe we can make a good team and we'll complete it as soon as possible. And I hope you will get a job as soon as possible as well. Uh, yeah, can you guys introduce yourself?
Hello everyone, my name is Shiva.
Hi everyone, my name is Bharat.
Hi everyone, I'm Ajay.
Okay, that's fine. So, like, do you guys have any idea about networking? Like, any basics?
No, not at all.
Okay. Okay, I'm just sharing my screen. So we need to start from scratch, right? Just a minute. Okay. So usually in networking, so like normal in general way, what is mean by networking? So right now we are connected, right? So we are in a Skype meeting. That means so we are connected through something, right? And so if a group of devices connected to the together, that's called a in physical way you can call it as a like it is a LAN, and in logical way we will call it as a networking. Okay, but if I give you a simple example, sorry. So there are two devices. So that might be anything like your laptop or any switch router, whatever it is. So how they will communicate, like how you are communicating through your how we know you are the guy, you are Bharat or you are Vinod or you are Kiran. So you have some identification, right? You have your own mobile number, so for your device, so we are able to communicate with that only, right? So same way, in network we will have a logical address for your physical device, that is called as a IP address. Okay, so by using this IP address only, everything will communicate in the network. So, and before going to that, we have some network topologies actually. Like how you will connect your devices. So there might be a way, right? So like suppose in your example, there is a guy will come and connect a Wi-Fi router. So that is one physical topology. And if you see offices, they all sit together and they'll connect through a LAN cables. That is also one topology. And we are connecting through the Wi-Fi to the Wi-Fi. That is one topology. So these are all the basic things. If you go anywhere, you will see either one of the model. So in this network topologies, so you have to see, you have to identify. Suppose if you become an architect, maybe you need to find out which topology we need to implement here. What is the best solution for my organization? So that way we need to figure it out. So like the physical representation of the network is called network topologies. We have like specific types. One is sorry, start. Okay, so basically these are the five models we have in the network topologies. Um, so it's basically how you will connect the devices. So it doesn't mean like you have to build something new. We already have the existing topologies, so you need to use either one of them. Suppose if I take, for example, bus topology, um, yeah. So this is how it will be. Okay. So in simple way, Cloud, like normally, so all of your devices will be connected to a single line, like a single LAN cable. And just let me know. Suppose if your device one PC1, if you take it as a PC1 and he is a PC2, for example. So he wants to try to communicate with this guy. So he needs to go through this, he needs to go through this, and he needs to come here, right? So if in case in the same way, at the same time, PC1 to PC2 is communication is going on, but in the PC3 to PC4 also at the same time, 3 to 4, the same time also we need same thing, need to be happen. So if they both started communicating together, so the both packets will meet here, maybe not not the first time, maybe sometime. Maybe they will reach, they will hit together and the data will be collapsed here. So it is a single line. And one more thing, in the bus topology, this is simple to implement. Like if I say in your home, you have two laptops. So if you connect a LAN cable between those two, it will become a bus topology. Maybe if you have a multiple NICs to your laptop, and if you connect multiple cables, yeah, then you can connect it to the multiple devices, right? Like for example, this is your PC and this is mine, so we connected together. I have two NICs, so I'll connect it to another guy's PC, and I'll connect it to another guy's PC. So we are in a single line and we are connected using a single LAN cable. if suppose if suppose, for example, this cable has some issue, so this has some issues, so then so this guy won't be able to communicate with any of them. So he is now single. So like he is a standalone. He was not able to connect to the any one of them in the network. Same way with other one also. Like suppose if something broke with this guy, so he will not be able to communicate with any of them. So that is how there is no redundancy. So in network, so whatever the technology you learn or whatever you do doesn't matter. So the main thing is redundancy. We should always have the backup. Like for example, if I take your mobile, we have an option called Wi-Fi calling, right? So suppose if your phone, if your phone doesn't have any signal, so it will go through the Wi-Fi. So we have a Wi-Fi calling option. So then that is an alternate option. So maybe people can reach you because you have Wi-Fi calling option, and they will reach you through your number only. There is no need to do any other thing. The same way, in the network. So network is a big part. Like if something goes wrong, yeah, no one able to connect to the anything, and then it is a big mess. Maybe if one server goes down, only for that particular servers will affect. But coming to the network, if anything goes wrong, entire organization will affect. So we are in a hypothetical situation, like every time we need to resolve all the issues in a short time, and they'll force us to do it also in real time. So that's why the redundancies matter. But in this case, we don't have that. If you see, we don't have any redundancy in bus topology. But it is simple to implement, and this was the first one invented actually. Hope you're understanding. If not, just let me know. I'll try to explain in a better way. Oh, hello.
Yeah, yes, sir.
Yeah. So you guys understanding, or maybe still we need to do some changes?
No, yes, we're fine. I think I'm fine.
Okay. Okay. So next one is ring topology. So normally ring topology will be like this, like the same ring way. So basically, it will be in a circle manner. So this ring topology, and okay. So here, suppose this device wants to connect to device 4. So it has two ways. Either it can go via device 2 or it can go via device 3. But it has to be always full ring only. Like suppose if this device goes down, like for example, device 3 went down and device 1, device 2, device 4 are online, but still you have not formed the ring, right? So your data will not be transferred. Okay. And one more thing in this ring topology is the data delivery. Like if you see the integrity, like so the data, whether it can transfer the data to the destination or not. So that chances we have very high here. Like it will have a token system. Like suppose if you initiate a connection between device 1 and device 4, so you'll get to know. Like once we go into the other things, I'll let you know a few things. Like it will create a frame with a token number. Okay, so in that token, and in between, while it was doing device 1 to device 4, suppose device 3 wants to send some data to device 1, so it will call that a token. So here it is called a token ring actually. So that token will carry the data. So device 1 to device 4 is already in transmission, right? In between, you say like I want to send data from device 3 to device 1. So but what it will do is like it will not drop this data here and it will not come to you. So first it will complete the device 1 to device 4 transaction and then it will report back to device 1. So then only the token will get released. So then it will come to device 3 to transfer the data between device 3 to device 1. So in the same way, if you are in device 3 to device 1 transition and you want to send some data between device 2 and device 4, you will call the token. So with this token, only you can transfer the data. So then the device 3 needs to release that token. So when it will release, once the transaction is completed, only then it will release. Otherwise, it won't release the token. So here you need to observe one thing, like suppose you want to send data between device 1 and device 4, but device 3, device 4 are disconnected, like they don't have any connectivity here. So in that case, what will happen mean? So you don't have any token here. The token is the main thing. Like if I say a single carrier here, for your network, yeah, Airtel is a carrier or Geo is a carrier. If you don't have Airtel and Geo, you won't be able to connect to any one of them, right? So simple way. Same here, it is a token. The token is the carrier here and it will carry the data from one device to another device. So, and it will form only during the full ring only. Like if suppose one device goes down, yeah, it won't go. Like it will not take it further actually. So yeah, so and suppose if you want to pass data from that device 1 to device 4, so sorry. Suppose if you want to implement it for 100 devices, so you need to have a big ring topology. But if something goes wrong in one link, the entire network will not work. So that is the drawback of this ring topology. And but yeah, these ring topology, bus topology we may have seen earlier days. A ring topology mostly we will not see in the real time. Um, but it is a one kind of the securable and reliable topology, because this gives us 100% confidence that like it can transfer your data without any issues because of this token. Okay, you will get understand easily once we move further, like about more once we are about more the topologies and more about the network, you will understand it easily. And the next one is star topology. So this one we are using regularly in the, like if you go to any office, you will see star topology only. So there is a hub or switch will be connected, and you will have your devices like this. Okay, it is a star topology. And so here the main advantage is like there is no dependency on the other devices. It will depend on only one device, which is a hub or switch. So we will use it as a carrier for our data transfer. Okay. Bus switch. So we will use this one as a carrier for our data. Suppose, for example, this guy wants to communicate between this guy. So the traffic will not go to any of other devices. Directly, it will come from your PC to this switch. Then it will forward here. Okay. In the same way, in the exact same time, this guy wants to communicate with the other guy. So you are coming to switch and it is transferring the other guy. So same way in Skype, I am talking right now and you want to talk with other one. So you can unmute yourself and you can talk, right? So here's Skype is a hub for us. But if there is no Skype, no, yeah, there is no communication for us. Same way, if there is no switch, yeah, we don't have any communication here. So here the main thing is the switch or hub, whatever we are using. I'll let you know the difference between hub and switch in future. Next class. So this hub and switch needs to be always online. Like if switch is down, so the entire network is down actually. Okay. It is in a single point of failure, but yeah, in real time we'll have multiple switches and multiple hubs, so there is no issue with that. We'll have always the redundancy. So that's how. But if you go anywhere or any office, or if you see, if you compare any situation, just imagine it with your Wi-Fi. Example, in your home, you will connect to the Wi-Fi, like multiple will connect to the Wi-Fi, and you will use it. But if you don't have Wi-Fi, like you connected multiple laptops, so you can take RDP one to another and another to another, so you can use in that way, right? But if you don't have that Wi-Fi, you don't have any connectivity between those two laptops. I'm talking not about the internet. In the same way, so here we are connected using Skype, so we are connected to some hub. So it's not local, but it's WAN level or it's application we are using. But this is also one kind of. In the same way, in physical infrastructure, you will see switch or hub you connected to. So you will not have one like for your server, you will not have dedicated switch. So there is only one switch, and for that you will connect multiple PCs, and then you will communicate. Okay, that's how it works. If switch goes down, yeah, entire network goes down. So, but it is the best practice, and it will not depend on any other devices to forward your data. Okay, so it will do like a one to one. Individually, it will depend. So it's based on, it's all based on the performance of switch actually, like switch or hub. So how it will transfer the data. Okay, but there is no dependency on individual clients like these PCs. Okay, so we don't have any dependency here. Only we have this is our data carrier. If I see, this is our data carrier. If it is up, it will carry the data. If it is down, yeah, there is no network. Okay, so and this is the main one everyone is using like right now. Okay, sorry. And the next one is mesh. If I go to mesh topology, yeah. Okay, so this is how our mesh topology will reflect in real time. So here, you will have redundancy. So from PC1 to PC4, PC3, if I want to connect, how many ways I have? If you see, I can go from PC1 to PC4 and then PC4 to PC3. This is one way. And another way is I can directly go from PC1 to PC3. So two ways. And I can go from PC1 to PC2 to PC3. Three ways. Yeah. If you want to have some latency, maybe you can go on this way also. Okay. So we have four ways to connect with one PC. Okay. Suppose if this goes down, so does it affect our network? No, right? It can go from here or it can directly have the connectivity. So it can go on this way. So that is how we'll set up the mesh topology. And this will not be used in regular cases, but yeah, if you see some kind of high availability situation, like if I take some army or air force, those kind of, in those stations they will prefer this kind of technology. And so because they need to have redundancy always, they'll not depend on anything. Like while till you troubleshoot the issue, they'll not wait, right? So they need to have the complete redundancy for each and everything. Like if one goes down, yeah, they need to have one another one up. That is how they'll connect. Okay. So here in the mesh topology, if one link goes down also, you will have the another one as a backup. So that is how it's a mesh. So you can have maximum number of connections from one PC to another PC. Okay, right now there are four PCs, so that's why we have four ways to connect to another PC. For example, if you have 100 PCs, you have 100 ways to connect to with another PC, right? So you need to think on that way. So whatever the amount of your network, yeah, but you need, your network is that much large. And just think it in this way, like the cost also. Suppose if you become an architect, you need to suggest, right, which one we need to use. For example, which topology is the easiest one and which is the cost effective, and we need to consider all those things. But here if you see for four pieces, for example, if we want to implement, our laptop will by default will only have one NIC card, right? So right now we have only one NIC card, but if I want to connect with other three pieces, I need to buy three more NIC cards. Actually, sorry, two more NIC cards. So for that two more NIC cards, how much cost it is? And if I take one more PC, for that also we need two more NIC cards, two more. So we need to consider all these things, and we need to suggest. So this is for pieces. And if you take it for another like other switcher hub, yeah, we will have multiple ports, but you need to have extra ports also, right, to connect to the external devices and all those. So that's why they will consider and design these topologies. Okay, like they'll prefer. So but yeah, this we will not see in some situations we will see this mesh topology, but yeah, the star is the main one we are using right now. Okay, hope you guys are understanding. Just let me know if you don't understand, because we can repeat it again. If we go further and if you ask again, it's bit difficult to explain, right? Yeah. And the next one is hybrid topology. Like if I say simply combination of any two topologies, like you can club bus and star, or you can club mesh and star. So or you can club star and ring. So in that case, yeah, we'll call it as a hybrid topology. So but if I take, so just simple bus topology is this one, like you will be connected by using a single line, and in bus topology we will be using these things like pieces earlier, but right now we will connect a switches or hubs. So this will be become a hybrid topology. So like the combination of any two topologies will be called as a hybrid topology. Okay, so that is how. If you go to ring topology, yeah, earlier we used it to connect with switches, switch to switch. But right now what we will do, we will connect with switch to switches. Okay. So that is like, yeah, combination of any two topologies will be called as a hybrid topology. Yeah, we can see some hybrid topology scenarios also, like in the manufacturing industries. You will observe these kind of scenarios. Okay. So if you want to try something in physical, yeah, hope you guys have the packet tracer. Maybe you can try the same thing. Yeah, I don't have it actually. So you can go here and you can download it.
Hello.
Hello.
Yeah, Vinod.
Yeah.
What is the exactly is a packet?
Sorry.
What is packet? Is it we are sending or
Sorry, I didn't get you. Can you repeat your question?
I'm asking what is packet?
Okay. What is packet? So in network actually, so you will have IP address, right? And I'll have my own IP address. So in network we will call it as a packet actually. That is the terminology we will use it here. It contains your logical IP address and the port information we are trying to communicate. So usually, yeah, so we are communicating by using mobile numbers, right? Same way in network, they will communicate using the IP address, but along with that, there will be a port assigned to it. Like whenever I want, suppose your PC wants to connect with internet, or you want to open something in the browser. For example, yeah, we will open google.com. Okay, so how it is communicating with this Google? So if you see simply, so this is the protocol, right? We are using. So here, if you see the padlock symbol, so the connection is secure. So it is using HTTPS protocol. So that is the protocol, and we are connecting through our public IP also. So the IP plus port, the combination we will call as a packet here, and everything will go on this with the IP and port only. So not with the single IP or not with the without port we will not be able to communicate with other thing, and same way only with the board we will not be able to communicate with any other thing. So we should have both. So like the physical way of address and the logical communication way also, because in a single time your PC will communicate with multiple things. Like right now I'm using Chrome, um, Microsoft Edge, Google Chrome, and Skype, Paint, Teams. So we are using these many things. So do you think it will handle with a single IP? Yeah, no. It will communicate with each. It will communicate with each and every application with a dedicated port. So that is how it will work. If I show you, so if you see the local address, it will represent. Right now, my address is this 129.41, and it is using the port 139 to communicate. So if
Vinod,
it
this
is established
not
with, sorry,
screen is
okay, you are not able to see my screen. Are you able to see now?
Yeah, Vinod, yeah.
Yes,
Yeah.
yes, yes.
So to see, I connected to Google, I connected to other things. So if you see, dedicated for each and every connection, it is using a dedicated port. So for this communication, I have a different port, and for this communication, I have a different port. Even though my IP address is same, but it is using a different port, right? So that's how it will differentiate each and every connection. So maybe for this one I'm communicating multiple times. So each time, so maybe this connection was on hold and I initiated maybe one more new one. So that's why it is using one more port. And for this it is using a 502.727 and HTTPS. So these are the ports, these are the destination IPs, and these are the destination ports I'm connecting. Okay, so yeah, so this thing, the terminology we will use here, it is a packet actually, um, and in layer two we will call it as this frame. Frame, like in layer two means from our PC to rest of the pieces, we'll call it as a frame, and from layer three, like your Wi-Fi to internet, we will call that is a packet because it has a IP and port information. But in layer 2, it will have only MAC information. Let me tell you that also.
Ajay, you will be learn these all the things in further means further classes also. We'll explain all the things in
Yeah,
further
yeah.
session also.
So we have seen network topologies, right? So the next one more thing is network devices. So the first one is hub, and then switch, and then router, then access point. Mm, each router, access point. Yeah, well, so we are going right. Firewall, hotels, basically. So these are the network devices you will hear actually. I hope everyone knows about all of these. So first, whenever the network was invented, the first device was hub actually. Okay. So the way how hub connects is, so this is how you will connect to the hub. Like if the connection means you will connect through a LAN cable and it should have a LAN port, like if you see Ethernet port. Okay. Um, so your pieces will be connected to the hub. And the advantage is here, earlier without hub we need to have only one, this one, only one Ethernet, but for your laptop, right? So you will able to connect with only one other PC. So like this, only one to one. If you want more, you need to insert one more NIC card. But after coming, after hub was introduced, so we can connect multiple pieces, right? Here if you see, we are connecting almost eight pieces to a single hub, so they will communicate without any issues, right? So like here it is reducing our cost also, like buying NICs to have more connection. And so here the main so now this is up. Okay, fine, you are connecting devices, multiple devices, that is an advantage. Okay, so that's a good thing, but you need to think one way. So how up will communicate? Like suppose if I want to send some data from this PC1 to PC7, how it will do it? on what basis it will communicate. And in the same way, if I want to do it from here to here, so how it will differentiate my connectivity between this to this, so this to this, so how it will do that. So this is a layer 2 level. And so we have a MAC address. Do you know about the, do you have any idea about the MAC address? Okay. So MAC address means, so we are talking about the NIC or Ethernet, right? So that will have a physical address. Okay. Sorry, let me share my full screen actually. So first you should have all the basic knowledge, because once you are in, yeah, they will expect everything from you only. Okay, so these are the currently my NIC cards. If you see, I have a Bluetooth connection, I have a Ethernet cable. Right now I don't have connected it, and Ethernet 2, this one I created. So this one will be created like when you have a VPN connections, like virtual adapter, this one. Okay, but this is a physical one. And Bluetooth also inbuilt. So this is also physical one. This is physical. This is the virtual. And right now I connected to the Wi-Fi. Okay, so if you see here, I have connected to the wireless LAN adapter Wi-Fi connection, and it is saying description. What is my NIC model? Okay, dual band wireless AC 7265. That is my model, and the physical address 60 57 18 C1 58 72. Okay. Suppose I'll do some hacking or something else, how they will trace me? So that they will trace me because of my MAC address only. Okay, that will be also called as a physical address. Okay, or you will do some something in your like in work area, and you will change your IP address and everything, but we will have MAC reporting. So we will get to know who did it. So we have the asset maintenance. So everything can be tracked via your MAC address also. If you are going to hide your IP, yeah, you will do it via physical address or MAC address. So these are the NIC cards actually. So this is the NIC. So this is the physical one. So the, like how you will identify this is a like a, so that should have some address, right? So that one we are calling a physical address or MAC address. Okay, and so for each everything, so for this one they will have this one has a different address also, because it's a Ethernet. Like you will connect cable to that, like LAN cable, you know, right? So you will connect a LAN cable to that, and it will have a dedicated address. So this is a Wi-Fi card. Okay, it will be inbuilt in your laptop or in your like your mobiles or whatever. Okay, so that will have a dedicated IP, like address. So that is a physical address. So yeah, so that one, the hub will communicate based on the physical address only, because You don't assign anything or just a minute. Okay. Here, so this one needs to communicate this with this PC, and the second guy wants to communicate with this fourth guy. So that is how they will initiate the connectivity. So what hub will do once it receives the connectivity request from this PC to this PC. So what it will do is, so the functionality hub, so it will send that packet to each and everyone, like in the network. Suppose I want to talk to Ajay specifically, but right now what we are doing, like I'm talking to everyone. Okay. In the same way, uh, whenever you receive some data, hub, what it will do, it will distribute all the data to each and everyone in the network. Okay. And one more thing, these all should be in the same network. Like a different network doesn't work here. Okay. I'll tell you the difference between same and different networks. Okay. Don't worry about it. So yeah, so it will distribute your data to each and every PC here. So, but while you are sending your data, you will mention, right? I want to transfer this data to Vinod. So then, so the guy will come and he'll ask, who is Vinod? Then I'll say, I am Vinod. Then he will deliver the packet to me. Same way here. So this PC1 will send a packet and hub will do the broadcasting. So you know, right? Broadcasting, like, so broadcast means so it will be advertised to many people, like how we are watching TV. So like Ma TV, if you take, that is a broadcast, because the same thing can be watched from anywhere and anyone. So same way here in this hub, so if it will do the broadcast, so it can be transferred to the all the devices. Okay, and so but while sending, I'll have my IP address details. So means suppose if I take for example, so this is 192.168.1.10, and in the same way I will mention my destination as 192.168.1.11. So it will see. So once you send in a request like, oh, I am the responsible person, so he will ask you some proof, right? Whether OTP or any identity card or something like that. So same way here also 1.11. So are you sure you are really 1.7? So for that, what it will do, it will verify the physical address, and then it will transfer the data. But here you need to understand one thing. So I want to send data to this guy personally, like this guy personally, but why everyone wants to know, like I'm sending some data? That's not a good thing, right? Okay. So yeah, okay, before going to that, I can say, like in hub we have two types. So one is active hub and another one is passive hub. Okay. So these are the two types. So the main difference, the functionality is same between all the hubs. So there is not much difference, but only the difference we have is uh, this active hub will also act as a repeater. So what is meant by repeater then? Okay. So this is your, so just take existing thing also, this is your network, and so same, this is your hub only. I'm not adding any extra devices. So this, once you configure your hub as an active hub, it will have an additional functionality called repeater. Okay, so repeater means, um, like you want to transfer your data from one place to another place. Okay, you are doing that right now. So you're transferring your data from PC1 to PC4, but after some reason, like after transferring from one to hub, maybe your data lost, your maybe your data will be lost or signal strength will be lost. The best example for repeater is if you go to railway station, they will not, so they have 10 platforms and they'll have, in each and every platform they'll have the Wi-Fi connection, right? So how they are achieving that? By using the repeaters only. Like they will not keep each and every new Wi-Fi connection for all the 10 platforms. And so maybe the Wi-Fi will be supported for 200 or 100 meters only, right? So after that also, how you will, the platform is very long. So if I say, and the single Wi-Fi is not enough. So how we are achieving it? So we are using the repeater. So what it will do is the main functionality of the repeater. So you are transferring some data, but in between your signal strength gotten some weak, like maybe due to some noise in your network, or maybe bad signal or something like that. So your um, transmission was like went bit low. So if it is in the same way, sometimes other guys won't be able to hear us. So that is the thing, they won't be able to hear us. But in between, if you put a repeater, what it will do is like it will analyze the packet, it will analyze this packet, and it will regenerate this packet with the original image, original strength actually. Like whatever we transmitted, like once you started, yeah, like maybe it has 100 kbps or 200 mbps speed, right? So maybe once it came here, it has 50 mbps only. So if you have a repeater, then it will regenerate the packet with the 200 mbps speed, and it will send it so that it can reach its destination. So that's how it works. So in the same way here, if you put a repeater, if you configure this hub as active hub, suppose if that is, this packet comes here, maybe it is not able to reach the destination, then in between what it will do, it will retransmit the packet so that it can reach the destination. Passive hub, yeah, that is a hub. Actually, the main functionality hub is whenever it receives a packet, it will do the broadcast. Okay, so the broadcast means everyone will be able to connect with all the device, like everyone will be able to receive the package whatever we transmit. Okay, and it is a layer one device. Okay, like it's a physical one, and yeah, physical device, actually you will connect your pieces to here. Okay, you can do the same scenario in your in our labs also. Okay, so you know, right, this thing, like we have data. So whatever we are talking data here in the computer language, it should be in the zeros and ones only, right? 0 1 0 1 0 1, like that only. So whatever the data it is. If I say IP address 192.168.1.1, so this is for our representation, but computer will see in a binary language, like 0 1 0 1 0 1 0, in that way only. Okay. So these are our network devices. Okay, like sorry, in that hub. So hub is simple, like it will do the broadcast, and it works on the layer one. Layer one. Okay, layer one means physical layer, and it will. So it has two types. One is active hub and another one is passive hub. So what is the difference between active hub and passive hub? Active hub has a feature called repeater. So what is meant by repeater then? So repeater will strengthen your signal and it will regenerate with the original transmission rate. So we can transmit that. Okay, to the destination. Sorry. And a passive hub, yeah, it will function as a hub. Same. There is no difference. Like once it receives a packet, it will broadcast it and it will send it to the destination. Okay, are we good with that? Like hub. Okay, so I'll take it as a yes if no response. Thanks. Okay, the first one is hub, right? And the second one is the switch. And it is the advanced version for hub actually. And if I see, so basically the switch will be like this, and you will have your pieces connected. Okay, and so here, so the main difference between hub and switch is like switch will not do the broadcast. Okay, so you know what is meant by broadcast, I think. So like once you have your data, it can be visible to everyone. Okay, before it going to the destination, it will transfer it to each and every device in the network. Okay, so here in the switch, it will do the broadcast, but only once. Like once you connect it to your switch, so what it will do is like it will send a hello packet. Okay, so it will send a hello packet to all the devices here. So it will send a hello packet to all of these devices, so that what will do like, so once you replay not only on the switch, if you connect it to any network on your mobile phone or your laptop or whatever the device, if you connect it to the network, the first packet going out from your device is your MAC address. Okay, the MAC address or physical address. So that is the main thing you need to understand. Like, uh, so okay, maybe you will go as a firewall engineer or you will go as a some architect level, but if any issue comes, we will start from the scratch only. So that is the basic things you need to understand clearly, and you need to have idea about each and everything. Then only you can do the troubleshooting easily. Otherwise, you won't be able to do it. Like that time to verifying the MAC address, you can't bring in a Microsoft engineer because that is the basic thing and everyone should have idea about it. So the client will say like, why we need a Microsoft engineer? I'll guide you. So that is a bad thing for you during that time. So okay, so switch. So it will do the broadcast only once to lend the MAC addresses from the each and every devices connected to it. So what it will do is it will form a MAC address table actually. That will be called as a MIT table. MAC information table. Okay, so what it will do, it will keep the track of all the devices connected to it. Suppose if this device is disconnected, so there is a timer for it, like how much time it should wait. I don't remember the exact time. I'll let you know that later. So if this device is disconnected, maybe it should wait for some time, like 240 seconds or something like that. There is a timer for that. It will wait, and if it doesn't come back, it will remove it from this MAC address table. So why it need a MAC address table? So in layer 2, so hub bed layer 1, right? Layer 1 means the physical wiring. Layer 2 means the device like your laptop and the switch. So these are the layer 2 devices. Those will communicate based on the physical address. Like if I say NIC, that is a physical device and it is connected to switch NIC. So switch also has ports. Okay. So we will connect our device there. So those two are connected via physical address, physical cable or physical device, and they are communicating through the layer 2. Okay, so here the layer 2 means the MAC address. So the physical connectivity is there. The next thing is how they will communicate. So the physical address. So physical address is MAC address and it will contain the MAC information table. Suppose I want to send data from here to here. Okay, so maybe you will have the IP address details, but if you are connected to switch, it will see the MAC information table only. So once your packet sends here, what it will do is it will verify the MAC information table. Like whenever you are sending your data, so maybe you will have these details like source MAC, that means your MAC, and destination MAC, like whom you want to send the data, and source port and destination port. So these are the four packets. Like in a packet we will have this information. Okay, so yeah, this information needs to be sent to that, once it receives by the switch, it will verify what is the source MAC. Okay, this one is the PC one, it has some address. Okay, what is the destination MAC? Okay, so this is the destination MAC, so it will verify in the table whether it is there or not. So once it founds in the table, yeah, then it will forward your packet to directly to that device. Okay, so there are no intermittent devices or nothing like that. It will just directly deliver your packet to here. And if it responds, so same way. So if it is sending the data, then it will this IP like this MAC will be the source MAC and this MAC will be the destination MAC. So it will forward the data in this way. Okay, so once you go to the switch, the only thing it will do, like it will verify the MAC information table. If it is there, if it will forward, if not, yeah, it will drop the packet. Okay, hope you got it. This switch and router thing is will never leave you until unless you are leaving this network wall. Okay, so those two are part of regular life from now onwards. Okay, so the switch operates at layer 2. Okay, so I will tell you what is this layer 2 and what are all. We have a big concept called OSI model and we have a big concept called IP addresses. You will get to know everything, but yeah, these are the starting, because we are going to use this terminology like hub, switch, router. So just that's why we are giving just explanation about these things. Okay, so the router operates at a layer 3. Okay. So we are talking about the IP address, right? It will come here, the IP address. So it operates at layer 3 actually. And so for example, I'm just taking this as an example as a router. So usually I'll just give you just an example like how we will connect in real time. Just think it is your home network. this is router and switch. Okay. So here in the bottom, yeah, you may have PCs, multiple PCs. It's based on your switch model. Okay. So router and so this is your destination. Maybe yeah, google.com. So simple one, right? So this is the PC. I want to communicate with the Google. So how I will go there? So first I will initiate my request on my PC, like I'll go to my browser and I'll type google.com. So once you type there, it that request will go to your switch. The switch is a layer 2 device, it doesn't know anything actually. Okay. So what it's to do or something like that, it doesn't know. But if you see my IP config list, IPv4 address is this one, like this is my IP and this is a subnet mask. Yeah, I'll tell you about these two tomorrow. Default gateway. So this is the main thing here, the default gateway. So the gateway means whenever any connection comes or whenever any request comes from your PC, so the initial request should go to, like whatever the request, by default it should go to the gateway. For example, you have your mobile with you and you are trying to call me. So your is Jio and mine is Airtel. So what you will do? So first you will go to your carrier, right? First, like you will go to your Jio first. So like whenever you initiate, you type my number and if you click on call first, it will go to Geo, then it will verify where I need to go to find this number. Okay, so this is the gateway for this number, then I should reach Airtel. So then from Geo to Airtel, it will transfer the packet. So, so same way here, we should like if you assign any device with an IP, it should have a default gateway. So the default gateway IP is your router IP. Okay. So your router will do the all the layer 3 part, like it will take care of the multiple addresses communication. If I say, if you want to communicate in switch, if you want to communicate between different network, if I say different network means you are Airtel and I am Geo. Just take it in this way. Forget about IP addresses. You are Airtel and I am Geo. We will not be able to connect in switch level. If you want to connect between two different networks like Jio and Airtel, we should have a router. Okay, so the router will take care of this different network connectivity, because you are using Act Broadband and Google is using something other like a Pioneer. So those are two different vendors. So if they want to communicate, we should have a device who is capable to handle that request. So that is our router. Okay. So he will take care of the different networks communication. Hope you understand it. This is a very important one. Like, yeah, every day if you go anywhere, maybe you will see this router, switch, everything. So the router will we the main functionality of the router is like it operates at layer 3 and it communicates between different networks. So that is the main thing. Okay, but switch, it will never communicate between the different networks. It communicates between only same networks like Airtel to Airtel only, not with Airtel to Jio. Okay. So if you understand about hub, switch and router, so just tomorrow explain me the firewall and access point. Okay. So I'm just giving those to you like firewall and access point explanation. because if you understand switch, hub, or router, yeah, maybe you will explain it easily. I don't think there is much difference between the three and access point and firewall. Okay. Yeah. Uh, Kiran, I'll do one thing. Yeah, we'll stop here. And yeah, from tomorrow onwards, we'll go forward with. I'll share the schedule to everyone, and we'll go forward. Okay.
Sure, sure.
Yeah. So, guys, just one thing. It's first class for me with you, and for you also same. So if you don't understand anything, just feel free to ask me. Yeah, I can try to explain you in a better way. Yeah, I don't know. Like there is a one bad thing. Like yeah, I'm not able to write everything here. Yeah, I'm just drawing some lines. Yeah, but yeah, if you have any difficulty, just let me know. We can find a different way to explain because it is not for just training, right? You're trying for a job, so I know how it feels. So I just want to convey everyone like you should learn everything. Yeah, then only you can. Because I will give you as much as I can as a real time scenarios. But yeah, you should respond first. It's not like a one way traffic. We should have both ways, right? Okay then. Uh, so do you have any questions for me? Okay,
Uh,
take it.
Team, please respond everyone. Need your answers.
Yeah, that's what I'm expecting. Yeah, okay, maybe it is first class, right? Yeah, we'll start to see from tomorrow. Okay, no problem, guys. Thank you. We'll meet you tomorrow, 7 a.m. Okay, bye.
Bye.
Bye, Vinodya.
Yeah, bye, bye.
Hello, hello.
Yeah, bro.
ఇట్లా అర్థమవుతుందా లేదా? సరే, అతను ఇన్స్ట్రక్షన్ లెఫ్ట్ అయిపోయారు. మాతో మాట్లాడండి ఇప్పుడు. మీకు అర్థమవుతుందా లేదా? ఇట్లా
లేదు లేదు అర్థమవుతుంది.